And in today's episode, among other things, you'll see robots stop being just rigid machines and become trail companions, soft humanoids made to live among people, while others are testing the limits of their own bodies with stunts that defy physics. We'll also talk about chips as thin as human hair, which turn fabrics into wearable computers, and about a gene therapy that tries to restore vision by rejuvenating neurons directly in the retina. And meanwhile, scientists are taking brain-computer interfaces into space to understand how the mind reacts to microgravity. And as usual, when we put all this together, it becomes clear. We're not just creating more advanced machines. We're redesigning the relationship between body, mind, technology, and power. Let's try to understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Incredible Reality. Hey, Noma has launched a promotion called Flavors of the World, and you can win a complete gastronomic experience around the world, with airfare, accommodation, and a personalized culinary itinerary for you and whoever you choose. It could be in the United States, Europe, or Asia, or even one of the top 10 gastronomic experiences right here in Brazil. And if you liked it and are wondering how to participate, what do you do? To participate, just open your international Noma account for free. Download the app using the QR code that's appearing on your screen. Then go to the promotion website, register using the same Cadastro de Pessoas Físicas as your account, and start collecting your lucky numbers. At the moment I'm recording this video, over 3.5 million people already trust Noma, and that number keeps rising because the experience works. They have a high rating on Reclaim Acqui and a high card acceptance rate, whether in physical stores, online shopping, or during trips. And does all of this make sense? It's an international dollar account with automatic local currency conversion, using the commercial dollar rate, which is better than the tourism dollar. You can open your account and use it for as long as you want, okay? But for the promotion, you need to sign up by February 28, 2026. Go check the description, the pinned comment, or use the QR code that's on your screen. R20. That's my coupon, so please use it to support the channel. Thanks. You help me, and I help you. And Sentingente Technology presented a concept that shows the use of recreational technology, an explorer robot designed to accompany humans on outdoor adventures. The Hover X3 is not a humanoid robot. You can tell it's not an industrial one, and it also doesn't promise to replace anyone. What it has is 45 centimeters in height, and it was designed as a robotic Sherpa, capable of carrying equipment, climbing steep stairs, and crossing rough terrain while following its owner's every step. The idea is simple: to make your days easier. With the help of a machine, the Hover can carry backpacks on weekend hikes, automatically follow its user, and even go into patrol mode, monitoring the campsite against small intruders like forest animals. The company also suggests bolder uses, such as sending it to the playground as a kind of robotic babysitter. But that's where the line between usefulness and recklessness starts to become less clear. With a battery life of only about 6 hours, the X3 is far from being an epic explorer. What it actually represents is something else: an attempt to integrate robotics into everyday recreation. And the company positions the Hover as the first hover companion robot for outdoor use, a category that practically didn't exist until now. And if machines really are coming to be by our side in our daily lives, they need to be safe. Right, don't they? Humanoid robotics is known for metallic structures, exposed joints, and an industrial aesthetic. But that's starting to change now. Fauna Robotics, based in New York, has officially come out of anonymity to introduce Sprout, a lightweight, soft humanoid robot specifically designed for shared human environments. Instead of prioritizing brute strength and industrial robustness, the focus here is different. It's about coexistence. Launched as the Creator Edition, Sprout is introduced as a platform aimed at developers, researchers, and creators who want to explore applications in retail, entertainment, and domestic services. And all of this without having to rebuild motor control and hardware fundamentals from scratch. And this is where one of the main problems in the industry comes in: the so-called deployment gap. Many current humanoid robots are proprietary, closed, and expensive industrial systems. Or in some cases, they're academic prototypes that are too fragile to operate near people. And Sprout comes precisely to fill this gap. Standing 1 meter tall and weighing only 23 kilograms, it was intentionally designed to reduce kinetic energy and the risks of impact. Its exterior is made of soft materials, with padded panels that minimize pressure points. The idea is clear: to allow direct physical interaction even with children, without the robot seeming like a threatening machine. Aesthetics also matter. Fauna bets on emotional connection as a central part of the experience. Sprout has an expressive head, motorized eyebrows, and a face with a 100-pixel LED strip capable of conveying intentions and simulating visual emotions. Underneath this friendly appearance, however, there is a very solid technical foundation. The robot has 29 degrees of freedom and is powered by an NVIDIA Jetson AGX Orin. Its perception system includes a Z2i stereo camera for depth, time-of-flight sensors to avoid obstacles, and an array of microphones for voice interaction. In terms of software, the platform offers a modular AI architecture, allowing developers to swap models and adjust behaviors. The robot comes from the factory with pre-trained skills, such as walking, kneeling, crawling, and even dancing. It also offers teleoperation in virtual reality, compatible with Meta Quest 3 for data collection and imitation learning. Another important point is compliance control. Software-defined torque limits make the robot yield to extreme contact, thus reducing the risks in accidental collisions. Among the first clients are institutions such as New York University and University of California, San Diego, as well as companies like Disney and Boston Dynamics. Fauna makes it clear that they don't just want to sell a robot, they want to offer a kind of platform. For the next generation of embodied intelligence, Exploit represents something bigger than just a new product. It signals a cultural shift in humanoid robotics. Less focus on strength and more on coexistence. Less industrial machine and more social presence. Less industrial machine and more social presence. If the first humanoid robots wanted to prove they could walk and use strength, this new generation seems to want to prove they can live alongside us and maybe create soft and sociable robots. Solve the problem of coexistence. Maybe so, but there is still another much harder challenge, which is absolute body control, because it's not enough to just look friendly. You need to master every movement. And if there's a company that tests the limits of the robotic body very well and has been doing this for quite some time, it's Boston Dynamics. The transition between the lab and industry is rarely cinematic. Boston Dynamics thought the 3D research version of Atlas should end with something like that. As the company prepares to bring its fully electric humanoid robot to the business market, a final sequence of videos was released showing what many consider to be the pinnacle of bipedal robotics. Perfect somersaults followed by backflips, performed with precision that is almost superhuman. It's a fact the video went viral, but what really matters here isn't the acrobatics. It's what they represent. Behind the scenes of these moves is the RAI Institute, led by Mike Herbert, founder of Boston Dynamics itself. Together, they work to develop what they call physical AI, based on reinforcement learning and transfer, zero-shot, the ability to train behaviors in simulation, and transfer them directly to real hardware without any intermediate adjustments. This means that the robot learns in accelerated virtual environments and then performs in the physical world as if it had already experienced that situation hundreds of times. In the full videos, the company did something unusual that few talk about. They also showed the mistakes, falls, imbalances, failures, transparency that reveals something greater. The path to robustness goes through repeated failure, and this research phase was dedicated to testing the absolute limits of mobility, full body coordination, and simultaneous contact strategies between arms and legs. The goal was to go beyond simple locomotion and explore dynamic tasks that require manipulation while the robot moves, such as opening doors, operating levers, or running while carrying something. But this phase is coming to an end. The production Atlas has already been chosen as the best robot at Consumer Electronics Show 2026 by the CNET Group. Now, it leaves the demonstration stage to enter factories with 55 degrees of freedom and a four-fingered gripper. Equipped with the Astatus sensor, the new electric Atlas was designed for high-volume industrial tasks. Hyundai has already confirmed its deployment at the Metaplan America factory in Georgia, with a planned start in 2028. The initial focus will be on parts sequencing, then complete assembly of components by 2030. Boston Dynamics' strategy remains clear: to treat the humanoid format as a software problem. Instead of creating rigid and specific automations, the company wants a robot that can be reprogrammed in days, not redesigned over months. What we're seeing here is not just the end of an experimental phase, it's the passing of the baton from research spectacle to industrial routine. If somersaults were the symbol of boldness, the factory floor will be the test of maturity. Atlas is no longer trying to impress the internet, he's already impressed enough, hasn't he? Now, he's getting ready to really work. And when a robot can run, jump, and spin in the air, it's clear that the body has evolved, you can tell. But what really defines the next revolution isn't in the joints, it's in the processing. And now, that computational power is leaving the rigid board so it can become fabric. That's right. Historically, microchips were built under a rule that's almost unquestionable. They need to be flat, rigid, and made on silicon wafers. Now, researchers at Fudan University in Shanghai have decided to break that logic. Instead of trying to adapt traditional chips for fabrics, they did something more radical. They turned the fabric itself into a computational system. The result is ultra-thin fibers, as thin as a human hair, capable of incorporating complete electronic circuits into their structure. I'm not just talking about sensors or conductive wires. I'm talking about microcomputers wrapped in the form of a thread. Led by Peng Huxiang from the Chinese Academy of Sciences, the team spent more than a decade developing what they called FICs, fiber integrated circuits. The process starts with a stretchable polymer sheet, smoothed until it reaches a roughness of less than 1 nanometer. Under this flexible base, traditional lithography techniques are applied to build transistors, resistors, capacitors, and diodes, just like in a conventional chip. Then, this flat chip is rolled up like a sushi roll, forming a compact spiral that turns into a sealed fiber. The result is surprising. Each centimeter of the fiber can contain about 100,000 transistors. A single millimeter already integrates tens of thousands of them. In a full meter, it can reach millions, approaching the scale of traditional CPUs. But perhaps the most impressive fact isn't the computational power. It's the durability. The fibers withstand more than 10,000 cycles of bending and abrasion, and can stretch up to 30%. They were twisted up to 180 degrees per centimeter, withstood more than 100 machine washes, endured temperatures up to 100 degrees, and survived being run over by a 15-ton truck. All this while maintaining full functionality. Unlike previous generations of fiber electronics, which focused only on power conduction or simple sensors, this new technology integrates power supply, sensing, processing, and even display into a single filament. It processes digital and analog signals, performs basic image recognition with an architecture inspired by neural networks, and operates with a complete computing system, only flexible. This completely changes the game for wearable technologies. Clothes that process data locally, surgical gloves capable of transmitting tactile sensation in remote surgeries, brain-computer interfaces compatible with the soft tissues of our human body, and virtual reality devices that don't need external rigid modules can now become a reality. According to the team, this is the key to the next generation of electronics integrated into the human body. Because the body isn't made of silicon, of course, right? It's made of soft tissue. And now, for the first time, computing is starting to speak that same physical language. And when processing, sensors, and intelligence become part of the fabric we wear, the boundary between technology and biology starts to become increasingly blurred. If computing can already be sewn into clothes and bent like a strand of hair, the next step is inevitable, bringing the machine even closer to the mind. And when this connection reaches the human brain, the boundary is no longer technological. It becomes biological and even spatial. Until recently, brain-computer interfaces, the chips they're putting into people's heads, were only tested in highly controlled laboratories, protected from radiation, microgravity, and also the vacuum of space. Now, according to Chinese authorities, all of that has changed. A team from Northwestern Polytechnical University reportedly carried out the first in-orbit verification of a fully wireless, implantable brain-computer interface. The device was sent into space last December using a platform dedicated to orbital experiments. The goal was straightforward: to find out if a system capable of reading brain signals could survive and function, of course, outside Earth's atmosphere. And it worked. During the experiment, the brain-computer interface was placed in a simulated body fluid environment, reproducing real biological conditions. And even when exposed to the extreme conditions of space, the device maintained stable electroencephalogram signal collection. This means that the sensitive neural components, which are traditionally fragile, did not short-circuit, did not degrade, and did not lose accuracy. According to the researchers, the test fills a critical international gap by proving that neural electronics can operate beyond Earth. But the impact goes beyond engineering. Space causes profound changes in the human brain. When we leave Earth's gravity, the so-called cephalic fluid shift occurs, meaning that blood and cerebrospinal fluid move up toward the head. Prolonged missions have already shown an increase in the size of the brain's ventricles, as well as cognitive changes and changes in how the brain eliminates metabolic waste. Until now, these defects were studied indirectly. With a functional brain-computer interface in orbit, it is now possible to monitor neural activity in real time and map how microgravity reconfigures the human brain. This is crucial for long-duration missions, which will require years in space. China has officially classified brain-computer interfaces as one of the 6 industries of the future, all within the much-discussed 15th five-year plan. The stated goal is to integrate BCIs into the healthcare and manufacturing sectors by 2027 and to establish global industrial leadership by 2030. Here on Earth, the challenge is a bit different. It's not just about tracking neural signals, it's about restoring neurons that have already been lost. And for the first time, scientists are trying to rejuvenate cells to restore something that seemed irreversible until now. Losing vision due to optic nerve degeneration means a sentence that is almost final. The damage happens, the neurons die, and there is no regeneration. However, from now on, a biotechnology company wants to change this logic. Life Biosciences is bringing an experimental gene therapy called ER100 to the clinic, an approach that doesn't just try to slow down the disease, but actually rejuvenates the cells of the retina. The proposal is to redefine the aged neurons to a younger and more functional state through epigenetic reprogramming. The target is the so-called optic neuropathies, a group of diseases that cause irreversible vision loss. When the retinal ganglion cells die, these cells are responsible for connecting the eye to the brain, and once lost, they do not regenerate naturally. The therapy is based on the partial epigenetic reprogramming platform developed by Life Bios. Instead of altering the DNA, it modifies the biochemical markers that regulate which genes are activated or silenced, the so-called epigenetic patterns. The method uses 3 transcription factors known as Yamanaka factors: octamer binding transcription, 4 sex-determining region Y, box, 2 and Kruppel-like factor 4. Collectively, they are called OCT4, SOX2, KLF4. These factors are capable of reversing cellular aging patterns, restoring methylation marks associated with younger cells. In preclinical studies, R100 was administered directly into the eye through intravitreal injection. According to the company, the results showed restoration of methylation patterns linked to cellular age, improvement in visual function, and observed efficacy, including in non-human primates. This data led to Food and Drug Administration approval for the first clinical trial in humans. If it works, the impact will go far beyond that. Ophthalmology. Life Bio has already indicated plans to expand the platform to other age-related diseases, where accumulated cellular damage is the central factor. Reprogramming cells to restore their functions shows just how far biological engineering can go. But while medicine advances to preserve the human body, artificial intelligence advances to protect territories. And now it's not just in laboratories or hospitals, it has literally taken off. The silent war happening underwater has just gained a new hunter. On January 16th, the autonomous helicopter Proteus, developed by Leonardo for the British Royal Navy, made its maiden flight, marking a decisive step in the integration between manned forces and systems controlled by artificial intelligence. It's not just another military drone, it's not a full-scale helicopter. With 3 tons of payload capacity of 1 ton, a maximum speed of 260 km/h and an endurance of up to 5 hours of flight. And its main mission is anti-submarine warfare. The launch of the Proteus comes amid a strategic reconfiguration of British defense, based on the 2025 Strategic Defense Review. The new model does not rely exclusively on ships, submarines, and manned aircraft. The proposal now is a hybrid air wing, a combination of conventional platforms with autonomous systems operating together, that is, AI controlling machines. Proteus is a central piece of this mechanism. Unlike traditional drones, it is not just remotely piloted. Its internal software allows for autonomous decision-making during the mission, which will be expanded as testing progresses. And of course, its appearance will probably change as the technology matures. But the concept is already clear. The war of the future is unmanned. It will be connected and largely assisted by artificial intelligence. Combining everything we've seen today, you see these aren't isolated stories, right? More human-like robots, fabrics that process data, brains being monitored in space, cells being rejuvenated, machines making decisions on their own. We're not just creating technology, my friends, we're expanding the power of our civilization. Yeah, if you like this episode, go ahead and leave your like and check if you're subscribed, okay? Thank you for sticking with me until now, and I'll see you in the next one. Just click on one of the 2 suggestions on your screen. Thanks, bye-bye.